Okay, good morning all of you. Yesterday we are discussing about the types of the colloids based on nature of the colloidal particle. We already learned three types. One is multimolecular source, and another one is macromolecular source, and third one is associated source. Associated is relatively some important concept here. There we are discussing about the Kraft temperature, CMC. What is the Kraft temperature? The aggregation of the particle, nothing but micelle formation, will be taking place above a particular temperature, is calling as a Kraft temperature. The micelle formation will be takes place above a particular concentration of the solution, is calling as critical micelle concentration. Generally you take a soap solution, but maintaining critical micelle concentration, definitely what happening, the soap particles is undergoing aggregation and becoming like a spherical bodies. Yes or no? Those only calling as micelles. Okay, see, once I am explaining that thing, that soap particles are aggregate together becoming like a spherical bodies. Spherical bodies we are getting. Okay, here what happening, the soap has two types of the parts in it. One is polar head and non-polar type. So you take this soap solution at CMC in the water, what happening in it? Whatever head will be there, that will be staying on the surface of the micelle, yes or no? And whatever tail will be there, that will be going towards the center of the sphere. Array sir, why happening towards center? Why not staying on the surface? Yes, we have full clarity regarding this one. They are staying in which one, Amma? Water. Yes or no? This is nothing but water. You know water is of which nature? Polar nature. And head is having which nature? Polar nature. According to solutions like dissolves in like, means this is polar, this is also polar, that's why they are undergoing interaction. And which is repel with water? Tail, because it is the yes, nothing but hydrophobic part. That's why going away from the water and they are forming like a spherical bodies. Those spherical bodies only we are calling as micelles. Are you getting or no? Yes. And now we are discussing about one of the important concept. Same thing will be coming in chemistry in everyday life. That will be removed right now in second year topic. Even though how to learn that one, it is nothing but cleaning action of the soap. Cleaning action of soap. How soaps are useful to remove the oil marks from the clothes. Very nice concept. Observe very carefully. First of all, I am taking cloth. I am taking. So on this cloth some oil marks or grease marks will be there like this. Are you getting on? This is nothing but which one? Oil mark will be there. Now I want to remove that oil marks from the clothes. For this what I am doing, I am soaking or I am dipping this cloth in a soap solution. Soap solution. In already soap solution what will be there? Micelles will be there. Are you getting or no? Yes, micelles will be there. In this micelles, polar head will be there and non-polar tail will be there. Are you clear or no? Yes, in that soap solution already micelles will be there. Is going on. Now, whenever you take that oil marks having clothes in that soap solution, what happening anybody? This micelles will undergoing a breaking into a small particle. Then what happening? From this micelle, which part going into the oil mark and which part staying on the oil mark? Means mechanism of the cleaning of the clothes by using soaps. Anybody? From these micelles, which part going into the oil mark and which part staying on the surface of the oil mark? Yes, you have to understand oils. Oils means what, Mama? Organic compounds. Generally, organic compounds are having which nature? Non-polar in nature. Whenever you dip this cloth in soap solution, from the soap what happening? Whatever non-polar part here, tail. That tail will goes into the oil mark. Means we have here clothes we have, and on this what will be there? Oil mark is there. Into the oil mark, which will be going, tails will be going, because tail is a non-polar part, oil is also non-polar, they will attract together. And which will be staying on the surface of the oil mark, polar part will be staying. While going like this, some changes is going in that oil mark and cloth interaction. Anybody? While introducing like this, the force of attraction between cloth and as well as oil or decreasing? Yes, very good, decreasing. Someone is pulling, no, automatically what is happening between both the oil mark interaction force will be decreasing. Now, you are leaving like that? No, you are giving washing with water. Continuously, yes, we have to take one more bucket of water, we have to pull it like this and wash it like this, it will be goes. Why? Again science is there, again chemistry is there. Anybody? Yes, very good Amma. Water is the which nature Amma? Polar in nature. Here which is ready on the oil mark polar part is there. That's why what happening? This head will attract with that whatever water you are using for washing. What happening? Between this head and this water, attraction will be increasing. With that attraction, what happening? Total oil mark will be coming outside. Then what will be there? We have clean clothes. Okay na? Yes, clean clothes, no oil marks. But here very nice chemistry is going on. What happening? This oil mark plus soap and water is forming one liquid. Is nothing but we have here oil mark we have. Yes or no? On the oil mark, what will be there? Head will be there. Yes or no? And like this will be going on. Head and non-polar part will be there. Along with which one it is coming outside? Water. Yes. Here, one important competitive bit is there. In the cleaning action of the soap, okay, we are getting cleaned clothes. Finally, we are getting one liquid. We are getting that liquid only we are specially calling as emulsion. Why? Yes, here disposal phase is oil, liquid. In which one? Water, liquid. Liquid mixed with liquid. That should be heterogeneous, calling as emulsion. Okay, one more thing I want to discuss here. If you take without soap particle, if you can take oil and water, is it mixed with one another? No. Means they always becomes like a layer. But here what happening? Is there any separation like that? No. Why? Why? This all interaction between oil and water because of which one? Soap particle. Means because of soap particle what happening? The force of attraction between oil and water will be going on increasing. That phenomena only we are calling as emulsification. Emulsification. Are you getting or no? And which is used to increase the interaction between oil and water. Soap, that's why soap we are calling as emulsifying agent. Emulsifying agent. Yes, these all are very important mixer. Yes, sir. You clean clothes, let it be. But the final mixer or final waste material is important to us. It is one of the chemistry related topic. Means basically oil came outside with water, but actually oil and water both are liquid medium. Liquid mixed with liquid. Actually we are not getting homogeneous, heterogeneous we are getting. So it's calling as a colloidal mixer. That is specially calling as emulsion. Basically between oil and water there is no force of attraction. But by using soap what we are doing? We are increasing the attraction between them. Means that they want to becoming like a soul. So the phenomena is calling as a emulsification. Which agent is used for this process? That is calling as emulsifying agent. So he may ask a question. So the removal of the oil particles from the clothes by using soap, the phenomena is undergoes emulsification. In this phenomena, which is acting as a emulsifying agent, whether oil or water or soap? So that's it. All of you clear? Yes. Now we are going to discuss some other things. See carefully. Preparation of soaps. Very very important. Preparation, properties, and uses. These all are very important. We will see. Preparations of soaps. Very nice concept. This is. Okay, preparation. We have how many types of soaps based on interaction? Liofilic and liophobic. First of all, I am discussing about the liofilic. Liofilic soaps are easily prepared. Yes or no? Easily prepared by just mixing of dispersed phase with dispersion medium because they love together. Yes, between dispersed phase and dispersion medium what happening? Force of attraction will be very high. Okay, that's why what happening? Whenever you mix them, they will mix it with one another. We are getting liofilic soaps. Is it necessary to use any special methods? No, just mixing. starch in water, protein in water, gelatin in water, as basically is going on. That's why no need to use any special method for the preparation of the lyophilic salts. But we are discussing about the lyeophobic salts among. Lyeophobic salts. Lyeophobic salts are difficult to prepare. Difficult to prepare. Why? Yes, between dispersed phase and dispersion medium, what happening? Force of attraction will be low or no. Less force of attraction will be there or more force of attraction will be there. But we have to mix them. If you want to mix them, you have to do something. Then we have to use some special method for the preparation of especially lyeophobic salts, because basically they don't want to mix with one another, but by doing something we have to mix them. For that lyeophobic salt preparation we have to use some special methods. Those we have two categories. A is first category for the preparation of lyeophobic salts is nothing but condensation method. Condensation methods. And another one is dispersion method. Dispersion method. Are you getting or no? No need to use any special method for the preparation of the lyophilic. But if you want to prepare lyeophobic, you have to do something. Means you have to use some special techniques. You have to use those techniques are two types. One is condensation method. Another one is dispersion method. Now, first of all, I am explaining about the condensation methods. Condensation method. I think you will get some idea by seeing this name. What is the meaning of condensation? Combination. What is the meaning of combination? What principle is going on here? I will explain. First of all, I am taking a solution. In the solution, what will be there? Solute particles is there, solvent particles will be there. Yes or no? These are solute particles, and also we have solvent. Are you clear or no? But these are nothing but which one? Solute particle size is which one? Size in solution? Less than 1 nanometer. Very good. But I want to make this one as a sol. What I should do? I have to increase the size of the dissolving particle. Possible by using some chemical reactions or chemical methods. By using some chemical reactions, we are making this small size of dissolved particles into colloidal particle size. Means what happening? The small size of particles are joined together. That phenomena only we are calling as yes. After condensation in the chemical reaction, what happening? We are getting big size of particle. We are getting. These are not coming from anywhere. These are formed by aggregation of small particle. I think you got some idea. These are also nothing but multi-molecular source. Because in these colloidal particles are formed by combination of so many small atoms or molecule under the size 1 to 1000 nanometer. These are colloidal particle. Size should be undergoes 1 to 1000 nanometers. Such components is calling as source. Are you getting or no? Yes. Here finally what happening? The small size of particles are aggregate together, becoming like a colloidal particle. The phenomena is calling as condensation method. If you want to do like this, compulsory you have to use chemical reactions. Condensation method is nothing but chemical reaction methods. Are you clear? Yes. I will give you some example here. First one. I am taking arsenic oxide. I am taking AS2O3. It is nothing but a solution. Solution means in that particle size will be too small. To that I am adding hydrogen sulfide gas. I am adding. What happening? Some aggregation will be taking place, becoming like a sol. I will explain to that one. You see carefully. I am taking here 3 moles. Then what happening? AS2 and 3S is becoming AS2S3. You learn this one in catalysis. Arsenic sulfide compounds is acting as a poison for contact process. In the contact process, platinum is acting as a catalyst, but arsenic compounds are acting as a poisons. It will slow down the activity of the platinum catalyst. Right? You are getting which one? Sol we are getting. In this sol, the dissolving particle size will be relatively bigger than solution particle. And which is coming outside? Yes, 3 oxygens, and here we are getting 3 moles of
of the water. This is acting as a which one? Dispersion medium. Over. These are colloidal particle, that is a dispersion medium. The mixture is behaves like a solid. Are you clear? Yes. Now here what we are getting, I am giving some other example. You take hydrogen sulfide plus SO2 you take. Whatever hydrogen sulfide will be there, it is becoming like a solution. Means in this particle size will be too smaller. It will be undergoing reaction. Anybody SO2 no? Yes, we are getting I think 2 moles here. Yes, 2 sulfurs plus 1 sulfur is becoming like 3 sulfurs. It is relatively bigger in size, means so many sulfur atoms are joined together becoming like a colloidal particle. It is also undergoes multi-molecular solid. Okay, then it is behaves like solid, but which is coming outside? 2H2O is coming outside. Are you clear? Yes. Can I give some other examples to convert solution into salts? For example, you take ferric chloride solution. Actually, it is a solution. It is a solution means the dissolving particle size will be too smaller. By using chemical techniques, making the size of the dissolving particle should be bigger. Yes. For this, I am adding 3 moles of the water. I am adding. After this one, what happening from here? 3OH. From here, iron. It is becoming like ferric hydroxide. Ferric hydroxide size is relatively bigger. Then it is behaves like a soap. Then which is coming outside? 3H and 3Cl is becoming like 3HCl. I want to prepare one more sol is nothing but gold sol. If you can take auric chloride AuCl3, RS chloride AuCl, lower oxidation state As, highest oxidation number for the same metal Ik, auric plus 3, AuCl plus 1 plus 3 which is more plus 3, so calling as auric chloride. Auric chloride will be reacting with stannous chloride. Why stannous? Sn has 2 oxidation state, plus 2 and plus 4. Relatively plus 2 is lower, so calling as stannous. If you take SnCl4, stannous, because their oxidation number of stannous will be plus 4. Okay, then you can do this one. You are getting here 2 moles and here 3 moles. Then we are getting 2 gold atoms. We are getting plus how many chlorines? 3 2s are 12 and 12 together 6. 6 plus 6 12 will be there. Then we are getting SnCl4. We are getting 3 moles. Now we got gold salt. It is also like a multi-molecular salt. If you take atom very small size, nearly 10 to the power of -8 centimeter, very small size, no, that's why those particles, those gold atoms are joined together becoming like a colloidal particle size. That's why we are getting here gold size will be a little bit bigger than this one. That's what is calling as a so this polar under comes which one? Condensation methods. Now we are discussing about the second technique. It is nothing but dispersion method. Dispersion method. I think you got some idea. Dispersion means what? Decomposition. Dispersion is what? Decomposition. What is happening here? If you take precipitate amount. Precipitate means in that particle size should be, yes, very good amount, more than 1000 nanometer. Is it calling as a salt? No. I am doing something. By doing something, what happening? I am breaking this precipitate particle into small particles. Those particle size should be in between 1 to 1000 nanometer. Such kind of particles only we are calling as colloidal particle. The resultant is calling as a dispersion. Means we are taking a freshly prepared precipitate. We are taking. Actually, the size of the particle will be too bigger. Now, by using some techniques, I am breaking the precipitate into little bit smaller pieces, and the range of size is 1 to 1000 nanometer. Then it is behaves like a sol. Here, what happening? Big particle break down into small size particle, calling as dispersion. But here reverse. Small size particles is joined together, becoming like a colloidal particle. Yes or no? And a dispersion medium will be there. It's not a matter to us. Okay. Now, under dispersion method, I am giving one of the important question for 5 marks. Is nothing but Bredik's electric arc method. Electric arc method. You see very carefully. It's a very important and very easy also. You have to understand the concept carefully. Bredik's electric arc method is one of the method for the preparation of the leophobic soles. Here principally is dispersion is going on. Especially it is for preparation of the metal soles. Metal soles. I told yesterday metal soles are leophilic or leophobic. Leophobic, why? Because metals, heavy particle always want to separate from the water. But by doing something, we are increasing the interaction between metal and water. That's calling as some techniques we are using here. So metal soles means especially it is used for gold sole and as well as silver sole. Okay, first of all, what is the technique here? First of all, you observe very carefully. First of all, I am taking one vessel. I am taking. Okay, for example, I want to prepare the gold sole by using Bredik's electric arc method. Which metal sole you want to prepare? That metal rods has to be taken as a electrodes. Means I have to take which rods I have to take? Which rods I have to take? Gold rods I have to take. Why? Because I want to prepare gold sole. These rods will be connected to high voltage battery. Nearly 10,000 volts battery, that to DC current, direct current. Okay. Now these rods has to be dipped in water. These rods has to be dipped in water. Okay. Along with this water, I am adding little bit alkali. What is the meaning of alkali? Base, alkali metals, alkaline earth metals. Anyway, alkali means base. So along with water, I should take either little bit potassium hydroxide or sodium hydroxide. This is very helpful. For one mark, he is asking, what is the necessity of adding of KOH or NaOH under this process? I will explain that one. First of all, how to take like this, and again this total equipment kept in ice bowl or ice vessel. Yes, here ice cubes will be there like this. Means how to take the total equipment in ice vessel. Okay, that's also I will explain what happened here. This is nothing but ice cubes. Okay, you have to take like this first. And start the supply or passing of 10,000 volts back electricity to these electrodes. What happening, at the end of these rods, one electric spark will produce. Nothing but like bright line will be forming. Means spark. Like while colliding clouds, how spark will become, such kind of spark will be produced at the end of the electrodes. What happening? That spark or arc, that only we are calling as spark or arc, that will be passing through this rod up to this end. Wherever water level will be there, up to that one, the spark will be passing. Why? Because in the air it is not possible. Because it requires some medium. That's why from here to here always continuously the spark will be passing from bottom to up to water level. Through this one, what happening? Metal rods or electrodes is becoming heat up. So while heating the metal rods, what happening? The metal particle is converting into gas phase, evaporation. Okay, after that what happening, I will explain one by one. You see carefully. First of all, I am taking a gold rod. I am taking. What happening? I am explaining here. The gold rod is basically which one? Solid phase. Means rod. It is indirectly nothing but precipitate. Precipitate means rod. No, it is big size. Now what you are doing? We are sending electrical energy. By sending electrical energy, what happening? Continuously that spark or arc will be passing through that rod. It will becoming gradually heating up. Definitely what happening? The metal or gold rod will converting into evaporation. Evaporation means what? Evaporation is water. They are becoming like gas particles. Yes. Gold particles are becoming gas particles in this. Now this phenomenon is calling as condensation and dispersion. Dispersion, because big size particles is break down into small size particles. That's why here dispersion is going on. Okay, those metal vapors cannot come outside. Why? Because the phenomena is going inside the water. Okay, that too the bowl kept in ice bath. We are maintaining at the same time very low temperature. Then what happening? The gas particle what happening? Becomes cool. Becomes cool means what happening? Condensation. Yes, again what happening? Condensation will be happening. Condensation means what? The small particles are aggregate together, becoming like which one? Colloidal particles. Yes, like that colloidal particle will be there. Okay, we are getting which one? So in this what happening? So many gold atoms are aggregate together, becoming like colloidal particle size. Compulsory size should be 1 to 1000 nanometer. But it is behaves here solution because one atom alone. But such kind of small atoms under cooling condition aggregate together, becoming like a multimolecular solid. Every colloidal particle containing so many gold atoms in it. That's why it is calling as multimolecular solid. Everything is okay, but we got sol. But what is the use of that NaOH or KOH? Okay, just I will explain to you. See, you have a sol. Right now you got in that what will be there, ma? Gold colloidal particles will be there. They are made up of so many gold atoms, and also dispersion medium will be there. Okay, my question, is it stable or unstable? Is it stable or unstable? Unstable. Why? These are metal particle. No, metal particle means heavy particle. Heavy particle means what happening? They may again close together and they may converting into precipitate. If once precipitate is formed, we are not calling that one as a sol. But I want to make a sol that too highly stable. For that, we are adding which chemical we are adding? For example, NaOH we are adding. So by adding NaOH, we can stabilize the sol. That is the main important amount. I told what is the meaning of stability and unstability. Don't compare that stability here. Stability means what? Always dispersion medium mixed with dispersed phase. If they are separated, unstable. It's not a sol only. That's why now if you leave like this, they are unstable. But I want to make it as a stable. Then what I should do? Unstable. But I want to make it as a stable. For that we are adding little bit alkali. We are adding. After adding alkali, what happens? This NaOH will be break down as Na plus OH minus. What happens now? This is the metal, no, electropositive will absorb negative particle. Then what happening? Every gold colloidal particle will absorb OH minus on it. Every gold colloidal particle will absorb OH minus particle on it. Then what happening? You see carefully. So we are getting dispersion medium. We are getting here. Are you getting or no? Yes. This is enough to explain the stability. After adsorption, again phenomenon is coming here. Adsorption. Only on surface, no chemical reaction, just sticking. After this one, what happening? Every colloidal particle is becoming negatively charged. All colloidal particles will be having same negative charge. Is there any chance to aggregate? No. Why? All are having same charge. Same charge means what happening? All colloidal particle is always repelled together. Repelled together means what? Continuously the motion. Within dispersion medium, there is no chance for settle down. Then it is calling as a highly stable. It is calling as highly stable. See, a very simple point and very important point. Why we should add alkali under preparation of rheophobic sols to stabilize the stoles? How it is happening? If there is no this alkali, the colloidal particles are chargeless. Problem. Those chargeless particles, heavy particles, so they may close together, may becoming like aggregate together, becoming like a precipitate. They will lose sol behavior. But I want to stabilize them. Means I want to increase the interaction between dispersal phase and dispersion medium. For that I am adding. After adding OH minus particle only sticking, why not Na plus? Metal should not. This is positive, this is negative, should attract. Then OH minus particle will be sticked on the surface of the sol particle. Then every colloidal particle is becoming negative charge. Like that, all colloidal particle will carry same signed charge. Then they always ripple together. Ripple together means they always in the motion. Then there is no chance so to settle down those colloidal particles in the system. That's why they are becoming highly stable. See, all of you got it up? Yes. Now we will discuss one more technique, very important, Amma.